Hi everyone, welcome to the channel Tech Tutor for You. This is Dr. Maheshwari. Today I am going to discuss about the basic elements of the communication systems. Before going to that, let me tell you what is communication first. Communication is nothing but conveying some sort of information from one place to another place, or from one point to another point, or one person to another person. Simply conveying or transferring some sort of information from one point to another point. It may be point-to-point communication, multi-point communication, network communication, etc. So, what sort of information we are going to transmit? It may be audio type or video type or any sort of text information we can able to transmit to the another end. That information to be transmitted is called as a message signal under the communication. The very two important signal under the communication to be noted is nothing but message and the carrier signal. So message signal, which is nothing but it has some useful information to be transmitted. That information can be carried by a signal called as a carrier signal. So carrier signal is nothing but used to carry the information from one place to another place. It is an empty signal which is used to carry the useful information. That is called as a message signal. In general, depending upon the signal to be used, depending upon the type of the signal to be used, a communication system can be called as analog communication system and digital communication system. System means it is going to perform some operation. So analog communication, the system can be deal with the analog communication means that is called as analog communication system. In the similar way, it may be termed up digital communication system. Anyway, there are two signals or named up analog signal and digital signal. These are all the type of signal. If it is an analog signal means it is nothing but a continuous time varying signal. It keeps on varying with respect to time. Each and every second it is going to be produce some value as an output. Hence it is called as an analog signal. Digital signal means it is not continuous. It produces the output in terms of some finite value or discrete in nature. For every second, it is going to produce some different output. It may be 0 or it may be any value. There is no continuity between the previous one and the current output value. So that kind of a signal can be called as a digital signal. A communication system can deal up with the analog type of signal means that is an analog communication system in general. Similarly, a digital communication system can deal with the digital type of signal in general. Both analog and digital communication system can be capable of transferring a signal from analog to digital or from digital to analog, or it is capable to communicate as an output in terms of analog. The general discussion behind the analog and digital communication is the message and carrier signal used under the analog communication system may be analog type of a signal. Under the digital communication, the message signal may be called as a data or digital type of information. The used carrier signal may be in the format of analog or a train of pulses. Mainly deals with the non-continuous signal under the digital communication system. A particular system can mainly deals with the majorly it can deal with the analog type of analog type of signal. Some of the sources, some of the textbooks have been used to prepare this video. These are all the textbooks as well as a Google search I have made. Coming to the main topic, which is nothing but the basic elements of the communication system using the schematic. Hence, it is called as a block diagram of the basic communication system. These are all the basic elements, as well as it is also called as basic components of the communication systems. Each and every block can be called as a basic element. One is the 5 basic elements are input transducer, output transducer, transmitter, receiver, and the channel or a media. So in the schematic itself, the functions of the each and every block is given. Consider the input as the any sort of information, useful information, maybe a sound or picture or any sort of a text information that is to be transmitted to the input transducer. That original information can be converted into a electrical signal that is to be the acceptable format by the transmitter. So the electrical signal is the accepted signal to the transmitter. Hence, at the input side, the input transducer is used to convert the useful information into the electrical signal. So what is the job of the input transducer? It is used to convert the original information into an electrical type of a signal. So that is to be transmitted to the another end through the transmitter. The transmitter is used to transmit the incoming signal to the another end, as well as under the transmitter so many processes will be taken over here. Anyway, generally here, which is used to transmit your input signal to the another end. The output of the transmitter can be called as a transmitted signal, is the electrical signal. The transmitter used to transmit the another signal to the receiver via the channel. Channel may be wired or wireless. Definitely, the channel disturbed by the unwanted signal, which is called as a noise, that will be added with the transmitted signal. So the addition of transmitted signal and the noise to be transmitted to your receiver, that is called as a received signal. The receiver receives the signal which is called as a received signal. Under the receiver, the reverse process which is carried out under the transmitter will be taken over. So many processes are available, I already said. The outcome from the receiver is called as a electrical signal. That is what you have transmitted at the transmitter end. That will be recovered at your receiver. That electrical signal to be converted into the original form of a signal with the usage of output transducer. So the original signal is recovered. That may be transmitted to your destination. This is the general explanation behind this schematic. Coming to the examples of the analog and digital communication system. For the analog communication system, I have taken a phonograph as an example. Phonograph is nothing but a simple instrument. For example, at the transmitting end, some audio information is given through the mic. That audio signal is amplified. That signal to be transmitted to this disc through this needle. This needle is vibrated. That vibration has been, that is through the rotation of this disc, this needle is going to be vibrated or producing some vibration. Not vibrated means it will produce some vibration. That vibration can be absorbed at the another end. So through this needle's vibration, that will be understood by this disc, that will be transmitted to your amplifier. Hence it is amplified and it is reached to your destination as a speaker, that can be named as a speaker. Similarly, under the digital type, it is able to handle a digital information or an analog information. we have to consider the digital sort of information to be transmitted through the transmitter. The transmitter transmit the information, digital information, to the satellite via the transmitting antenna. The satellite receives the information. Always satellite receives the information in terms of microwave frequency. Anyway, the satellite transmit the received information to the another end, that is at your receiver. The receiver receives the information from the satellite by the receiving antenna. That will be transmitted, that original information to be transmitted to the destination or any display device. This is the general example for the analog and digital communication systems. I told you already, under the transmitter, so many processes are available. One of the very important process to be carried out under the transmitter is called as a modulation. So I'll tell you the definition by means of a theory. So the definition of modulation is nothing but it is a process by which some characteristics of the high frequency carrier signal is going to be varied with respect to the instantaneous value of the modulating signal. Modulating signal is nothing but a message signal. So a high frequency signal is nothing but a carrier signal. So carrier is used to carry the modulating signal by means of a process called as a modulation. This is the process modulation is going to vary some typical characteristics of the high frequency carrier signal, not the modulating signal, because the modulating signal which has some useful information. So we are not going to vary the modulating signal technically. We are going to, according to the definition, we have to understand some of the parameters of the frequency carrier signal is going to be varied. If you want, I tell you the parameters, which is nothing but amplitude, frequency or phase of the carrier signal is going to be varied, which are nothing but the characters or parameters of the high frequency carrier signal. So according to that, so many types of the modulation has been given. Here in general, modulation is nothing but changing the characteristics of the carrier signal with respect to the modulating signal. In detail, the modulation can be classified into two types. One is continuous wave modulation, another one is a pulse modulation. Under the continuous wave modulation, the subcategories are amplitude modulation and angle modulation. The combination of frequency and phase modulation is nothing but an angle modulation. So in general, under the continuous wave modulation, the three categories are amplitude, frequency and phase modulation. Again, pulse modulation can be subclassified into analog type and a digital type. Under the analog pulse modulation, the three subcategories are PAM, PPM and PWM. Pulse amplitude modulation, pulse width modulation, pulse position modulation. Under the digital type, the two modulations are pulse code modulation and delta modulation. So many subcategories are there. Two major categories are PCM, pulse code modulation, DM, delta modulation. So continuous wave modulation, which is nothing but, I already told you there are two input signals. One is nothing but what? Modulating signal, that is message signal. Another one is a carrier signal. So both the under the continuous wave modulation, both the message and carrier signals are in continuous type. That is, these two signals are continuous in nature with respect to time. So a particular modulation handles a continuous wave signal means that is called as a continuous wave modulation. So under the continuous wave modulation, the three categories are AM, FM, PM. So the characteristics of wave, which is nothing but amplitude, time period means indirectly frequency, then one indirect parameter is phase. According to three different characteristics, the three different continuous wave modulation is framed. The first one is amplitude modulation. The definition is it is a process of changing only the amplitude of the carrier signal is varied with respect to the message signal, not a frequency or phase. Only the amplitude of the carrier is varied with respect to the message signal. In the same way, only the frequency of the carrier is going to be varied with respect to the instantaneous value of the message signal. Instant means current value of the message signal. That is frequency modulation. Similarly, the process of changing only the phase of the carrier signal is varied with respect to the instantaneous value of the message signal. What are all the other two parameters? Frequency and phase. So under the phase modulation, frequency and amplitude of the corresponding carrier signal is not going to be varied. So under the amplitude modulation, the other name of AM is AM with carrier. Then AM means it has some subcategories or subtypes under the amplitude modulation. The original amplitude modulation can be called as AM with carrier. Carrier means a carrier signal. If the carrier is suppressed, means generally it will be called as double sideband suppressed carrier amplitude modulation. I'll tell you DSB-SCAM afterwards, but anyway it is one of the subcategory under the amplitude modulation. DSB-SCAM is available, which is expanded as double sideband suppressed carrier. Is nothing but the carrier is going to be suppressed. Under the SSB-SCAM, one of the sideband is going to be suppressed as well as the carrier is also going to be suppressed. Hence it is termed as SSB-SCAM. Under the frequency modulation, there are two types of FM. One is narrowband FM, another one is wideband FM. These are all some classifications under the continuous wave modulation. Coming to the next type of a modulation, next type of the modulation is nothing but pulse modulation. Under the pulse modulation also we have analog type and digital type. What does pulse modulation means? It is a modulation which is used to convert a continuous wave into a discrete type signal. Discrete type signal means it has some finite value with respect to time. So under the analog pulse modulation, there are three categories: PAM, PPM and PWM. In the same way, under the pulse modulation, we have two signals. One is a carrier signal, another one is the modulating signal. The carrier signal can be used as a pulse under the pulse modulation. So under the pulse modulation, not the message signal, only the carrier signal can be used as a pulse type waveform. Hence it is called as a pulse modulation. So if it is a pulse amplitude modulation means the amplitude of the pulsed carrier signal is going to be varied with respect to the corresponding value of the modulating signal. The another parameter of the signal, another parameter of the carrier wave is width of the signal, which is nothing but, that is, the width of the signal is going to be varied. Width of the carrier wave is going to be varied with respect to the modulating signal, which is nothing but PWM. Similarly, the position of the carrier wave means the pulse wave, is going to be varied with respect to the message signal means that is PPM. The three categories are PAM, PPM and PWM under the analog pulse modulation. So under the analog pulse modulation, the carrier signal is used as a pulse wave. The message signal is used as a continuous time analog signal. Continuous type wave, which is nothing but an analog type. Under the digital pulse modulation, we know that the two major types are PCM and DM. PCM, which is nothing but which is used to convert the analog information into a discrete type of information, or exactly it is used to convert analog to digital conversion, that is analog to binary conversion. This is the general definition. Under the delta modulation is also used to convert all the analog information into a digital type, but this kind of a modulation is capable to transmit only 1 bit per sample. This PCM can able to transmit more number of bits, that is more than one bit can be transmitted from one place to another place as a binary value under the PCM. But under the delta modulation, only one bit can be transmitted from one place to another place per sample. So these are all the types of the pulse modulation. The another major important process under the communication system is deduction or demodulation. It is nothing but recovering the original signal, that is your message signal, from the transmitted signal. This process totally comes under the receiver, but it is one of the process is the reverse process of the modulation. That's what I have mentioned over here. The reverse process of modulation, which is nothing but demodulation or deduction, which is used to recover the original message signal. Thanks for watching this video.